A very good afternoon to one and all present over here. Hope my voice is clear and audible. So
Yes,
we'll be
Shrishma.
starting. Okay, Akshaya, thank you. Yeah, so we'll be starting the session now, maybe in a minute or so. Okay, thank you. So we welcome all the participants once again back to the afternoon session on virtual labs. So the afternoon session will begin now. So to start with, we'll have a quick overview on one or two labs on CS, which is relevant to electronics domain. Then the session will be followed by the domain specific demonstrations. Finally, the session ends with the session by one of our nodal centers, SIT Tumkur. So with this, I hand over the session to Akshaya. Over to you, Akshaya. Thank you.
Good afternoon to all. Hope my voice is audible.
Yes.
Okay. So myself Akshaya and I'm from NITK development team, virtual lab development team. So I'll be explaining labs from computer science under virtual labs, which can be useful for the EC stream. So I'll be sharing my screen now. I hope my screen is visible.
Yes, Akshaya.
Okay. So I hope the site for the virtual labs is vlab.co.in. So you can see here a list of streams available under broad areas of virtual labs. So to go for the computer science and engineering labs, you can just choose the link computer science and engineering, or if you want to go institute wise, you can just go through that. So under this computer science and engineering, you can see around 20 labs have been listed by different institutes. Most of the computer science and engineering labs are developed by IIIT Hyderabad. Currently, IIT Kharagpur labs are down, so one can go through other labs. So for demo purpose, I'll be showing two labs. I'll start with the computer programming lab, which is a basic one, can be used by any of the streams related to programming. So this lab is developed by IIIT Hyderabad. So this is the computer programming lab. I'll go with that. So here you can see this is the interface for this particular lab. See, you can see around 10 labs have been listed under this. UI may be different, but the explanation theory, procedure, pre-test, post-test and all. So I'll be choosing one of the experiment. For example, basic one, that is basic control flow. Here you can see theory, objective in the left panel. You can see objective, manual, procedure. So under theory, you can see a clear explanation about the topic that is explained here is given.
Excuse me, ma'am. One request. Since the domain is from electrical and electronics, if it is related to electrical and electronics, if you explain that, it will be very helpful. This is a basic computer, so we don't require for the electrical and electronic streams.
Ma'am, could you please explain the VLSI lab?
That is related to EC, that can be explained by other.
No, the session is EC, no, madam. Session is for EC. Yes. Sir, actually,
Sir,
that lab usually handled by the computer science department.
Government faculties, not by the department faculties, is not going to handle that subject or lab.
So what to do, sir? Shresha, ma'am? Shall I continue or? Okay, is it okay if I explain data structure lab? Any of the experiments from a data structure? For example, expression evaluation using stack. Okay, here you can see there are 3 labs for data structures. 2 are new, which are newly developed. And for the web development, you can see HTML lab. And there is a lab for artificial neural networks and VLSI lab also. Even for computer organization, there is one more software engineering lab, computer organization lab, speech signal processing lab. So these are the list of labs for computer science. For more labs under computer science, you can just go to the link there, which new lab development. So under explore labs, we have options like approved labs and labs under development. So under approved labs, you can see if you want to sort discipline wise, you can just click on discipline button. Here also you can see around 8 experiments are newly added. Like for example, computer networks, computer networking and security. These are the labs related to networks. So this is the fundamentals of computer networks lab. As of now, there is only 1 experiment added. Since there can be more experiments added later. So under simulation, if you just click on the simulation part, so this is like choose a class and enter the IP addresses for all these pieces and check whether all the pieces are in network or not. So this is one type of simulation under new lab development. You can even explore more labs under development part. So you can even there is labs for EC also here listed. You can just click on discipline wise. It will sort accordingly. So there are around 12 or 13 labs for CS. So this is about the labs for computer science. Whenever you have time, you explore the labs under computer science. So this is about CS from my side. If you have any queries, you can just put in chat box. I'll stop sharing my screen now.
Operating systems lab, can we have some small demonstration? Anyway, we can go to DSP and CCN lab later. 1-2 minutes, can we have what are the experiments under OS lab? Because OS is a even electronics and other things. Can we have it is my concern. Anyway, it's left to the participants.
Actually, this is a lab under development. So
okay.
Maybe it is not reviewed since it is not put in the main.
Okay. Then okay, ma'am. Then we can go to VLSI and DSP labs. Yeah. Oh yeah, that's right.
Hello. Shraddha ma'am, are you available?
Yes, Shresha. I am.
Okay. Yeah, thank you, Akshaya. Yeah, I think we can wind up with that. Yeah.
Okay.
So the session, I think Shraddha ma'am can continue with the session on the demonstration. Yeah, thank you.
Thank you, Shresha.
Good afternoon, everyone. So I will be taking you through a few labs in core EC and EE. So one is integrated circuit and other one is machines lab. So I'll directly take you through my demonstration. So I'll be presenting my screen now. I hope my screen is visible. So as right. Okay, so as we went in the morning session, this session will be similar to that. It will be a hands-on session, so request the participants to be with your computer or a laptop so that it is easier for you to perform an experiment along with me. So now going through the virtual labs as earlier mentioned, it's vlab.co.in and yeah, I'll take you to one of the new labs under new lab development. So we'll click on new lab development, and as Akshaya had already shown you that, so I'll not go into the details. So explore lab, and we have demonstration of labs, we have approved labs and labs under development. So I'll be taking you through one of the integrated circuits lab, which is in labs under development. So you just click on labs under development, and it will it will take you to this page. Correct. So this is labs under development page. So I just, if due to some network issues, if it is slow, I've already kept those pages open. So I'll just take you through those. So we have integrated circuit labs here. So this is under electronics and communication. You can see that integrated circuits lab. So you just click on that and it will take you to this page. So similar to earlier labs, we have an introduction here. A list of experiments, target audience, as well as course alignments. So I'll take you through the list of experiments. So in this, currently we have 6 experiments, and I'll just quickly go through one of the experiments, that is inverting amplifier. So I've already kept the page open. So we have an aim. Student should be able to choose component values for given gain value, consider circuit for given problems, and so on. Then we have a theory here. So this is again related to this particular lab, that is inverting amplifier. So all the details of the lab is shown here. So this is the circuit which we will be operating in the simulation. So so the circuit details, the formulas used to calculate everything related to that particular experiment theory is explained clearly here. And also pre-test. So we have aptitude kind of a questions here, and you can submit and see how prepared you are for this lab. And then we have a procedure. So this is a procedure as in all those other labs. For every experiment, in every lab, we have the procedure related to that particular experiment, how to perform this experiment. So now we directly take you to the simulation page. So this is our simulation page. The developers have already set as a task. So I'll not. Here you can see that this is our workspace. This area is our workspace. So I've already selected. So input type. We have 3 types of input type which we can select. These are the only things we can select. We cannot use external, or we cannot edit the already developed program here. So I'll be selecting sinusoidal input type. So when I select sinusoidal input and I take my cursor into the workspace, you can see that sinusoidal input image is following my cursor. So you just click wherever you want to place that equipment there. So I'll click here. So it's asking me to select the voltage. So I'll just take a dummy voltage value, somewhere around 10 volts. It is just for the demonstration purpose, and select the frequency value, so 500 hertz. So this is a pop-up question, a pop-up one which will appear when you select a certain equipment, a certain instrument. So click on OK, and so that value is set. Now we'll go to select since it's an inverting op-amp, we'll be selecting a type of op-amp. So we have +5 -5 VSAT or +12 -12 VSAT. So I'll be selecting plus 15 minus 15 we said. So place it. So similar to that earlier, when I take my cursor into the workspace, I get a op-amp there. And then now we select the resistors and other components required to rig up the circuit. So we'll require one resistor. So let's say 10 ohms. And then again a feedback resistor. So we'll place the feedback resistor here. So again I'll select 10 ohms. And then ground. So ground, let us place it here. And then again, so similar to all to select different components, you have to go to the select component and choose whatever the components you require. Mostly all the components required to rig up a circuit will be available here. No extra components are available. So that is it. So now we'll select a CRO to view the input as well as output waveform. So again, same thing. Now for the connections. So you can see that connect. And what you'll have to do is when I select connect and take, you can see a plus pointer there along with the, so you just click on one node and the other node which you want to make the connections. So I made that one connection. Similarly, we'll do, so here I'll do the connection. Click on the both the nodes, like you just have to click the nodes. You don't have to drag the cable here. So that is done. And again, this connection. So one more. And we'll do the ground connections now. Select here and select here. Don't have to drag the mouse. Just click on the two nodes which you want to connect. So this should be good. Now I'll connect the connections to the CRO. So we'll connect it to output. And this will be our input. So now that I've made the connections, as you can see in the theory, whenever you get your own time, the circuit is similar to what is shown in the theory. So now we have to switch on the system. So we can see the input wave generating and output wave generating here. But if I make a wrong connection, I'll just switch off this, and for the reason of demonstration, I'll just make a wrong connection. So one more thing, okay. So connect, I'll just do one more connection. Connect this to the ground, and now when I switch on, you can see that this is a wrong connection that I've already made. So so since that is why we don't get any input as well as output in the CRO, and also this cable is shown as red. So since it is a wrong connection, you just click on undo, and the earlier last connection that I've made goes off. So once again, if I undo, the similar to what we do in our normal computers, this is just that. You click on undo and the earlier connection just goes off. So if you click on clear connection, whole of the circuit connection goes off. Now, let me just switch on and show you with the output. Okay, simulating. So graph. Since the circuit is correct, I think there's some issue that as you could see earlier, there was a graph.
Input and outs are shorted, madam. I think just see.
No, sir, it's not, yes. Because that I mean I agree, but it is that because if it is a wrong connection, I would have gotten a red cable there rather than a green one. That is what I tried to demo. So you the green means all the connections that you have done as of now is correct.
Madam,
So,
plus and minus 15 volt, I think it is not connected.
This
no, sir,
as-
it's connected.
How about ground, ma'am?
So the ground is connected. So it is just if I refresh and redo the connection, I'll get the output. I would just say that as earlier, I think you were able to see that there was a graph generated here, right?
Okay.
In the CRO, there was a graph generated, and if you would have clicked on show graph, you would have gotten a zoom view of the graph with the time and this one. So,
Madam, what is the value of RL?
So RL value, I guess I had entered earlier. I just took up a dummy value. I did not go with the detailed value, load value. So yes, also you can follow the since I already did the connections. There in the pop-up, if you click on pop-up procedure, a procedure will appear here. So you can already see, like I did all the connections, it shows that. Here, only thing is the connection details are not mentioned. The basic details of how to operate the workspace, that is what is shown in the procedure. So since students will already be knowing the circuit and also it is shown in the theory part, so it shouldn't be an issue for the student to rig up the circuit. If time permits, maybe later on I can keep my redo the connections and show you the output. Maybe once all the connection later on after the session. But as of now, the connections are right. But maybe a refresh page would do, but it will take me more time since I've already done the connections and things like that. So I would request one of the participants to share their screen. I will redo the connection in my own time and present it once it is done. This is just the mistake of network. Maybe refreshing would do the right thing. So one of the participants can share their screen. Experiment, maybe an adder experiment in this lab itself. Is there anyone who is willing to take up this? Because this is under the new lab development, it will take you little while to go to this lab also. So if someone could demonstrate this, it would be helpful for everyone. So anybody can.
If not, maybe the same experiment could be done by one more person.
Just to make it clear for the since the operations here is a little bit different. That is why. So one of the participants, I request to share your screen.
Let me share, madam.
Yes, sir. Yes, ma'am.
Ma'am, can I share, ma'am?
One of the ma'ams already requested to share the screen.
Okay.
So, Bhuvana, ma'am.
Yes, ma'am. Yes, I'm sharing my screen immediately.
Yeah.
This is the adder circuit.
Okay, ma'am.
Okay. So
Yes.
what I do is I will take one more resistor.
Mm-hmm.
Okay. Then I should connect this to here.
Altaf sir, please stop your presentation, please. Bhuvana ma'am is already presenting. Yes, thank you.
All these resistors to the same terminal. What should I do?
Ma'am, just a minute. Altaf sir is presenting the screen. I would request Mr. Altaf sir to stop presenting your screen.
Okay, ma'am.
Ma'am?
1 minute, ma'am. Since I cannot see your screen, I am not able to help you out there.
Okay.
So can you represent, ma'am?
Yeah.
Is outside your organization as
Is it visible, ma'am?
Yes, ma'am.
Yeah. Now I just wanted to connect all these resistors to the common terminal, negative terminal.
Yes.
Okay. So what should I do from here?
So, ma'am, like
this and this, right?
Yeah.
How to connect
If it is
it?
not
Yeah,
taking,
it's coming. Yeah.
it's
Now this side I should connect some voltage, some 1 volt, 2 volt, 3 volt like that. Where it is available?
component feedback resistor. Ma'am, if you go to the procedure or theory, you have the circuit that which we will be operating. Not the procedure, but theory. So three
So this
resistors
procedure.
adder yes.
Let it be the same thing. I want to apply
Yes,
this
ma'am.
point 1 point. Where it is available this
No, ma'am.
voltage in the,
I'm sorry.
where this voltage is available, V1, V2, V3 equal to 1 volt, right? So here in component, where to select it? This V1, V2, V3 here.
Ma'am, you have selected an input, ma'am. You haven't selected an input, I believe.
Yes,
Let's
it is
select
there.
one input, yeah.
Okay. Then?
And place it in the input position.
Where it is available. Yeah. But it is not visible. It is coming here, but I could not.
You can scroll your screen down, ma'am, because we cannot. Now you can drag it there. Yeah, place
it's
it.
Not visible. See, I could be able to see here.
Yeah,
When
ma'am,
I
place
bring
it there,
here-
ma'am. You can make the connections there itself. So you can enter the voltage.
Okay.
Frequency.
Okay, let it be.
Yes, ma'am. Enter the frequency, ma'am, or else it won't accept your. You have to enter the numbers, ma'am. Numbers.
Okay,
Maybe 500 or just a dummy value.
Yes, one. Let it be.
Okay, fine.
Then?
Now you connect all the positive terminals to the resistors, ma'am. Connect, yeah.
Okay.
Similarly, all the resistors to the input.
Okay.
Yes, ma'am. Connect to the one of the resistor node, ma'am. Ma'am, click on OK.
Can be parameterized actually. Where, ma'am?
Connect to one of the resistor nodes, ma'am. That would make the connection. Ma'am, resistor. Click on one another. Or else click on the
Yes,
input.
it is connected. Now it is connected.
Done. So
Okay,
now you
this
have
to ground. This to ground.
Yes, ma'am. Negatives
Correct.
to ground.
And here to I need to connect some unity feedback only I will connect it.
Ma'am, if you click on select component, did you select the feedback resistance?
Okay, no.
Yeah, and also you have to select a load resistor, ma'am.
First feedback resistor I will take.
Yes. Select one node and another node, ma'am. It's negative, ma'am. Negative of the op-amp.
Yes. See, here I selected.
Yeah. And now
And
click on
here
yeah.
Yes, done.
Connections done. This will
Then
connect to the output of the op-amp.
Here to
Output.
here.
Yes, ma'am.
Here.
And the resistor. If you double click on one node, it shows shorted.
Okay, fine. Got it. Understood.
Understood.
So here, yeah. This end to this end. It's not coming now. See here.
Yeah, and that.
No, Shakti Dana, what I am.
Where it is.
Node, ma'am. Node, RF
Ma'am, I'm done with the connections.
Yeah, ma'am.
Let him share, ma'am.
Please share your screen. So, ma'am, you can stop sharing your screen.
Yeah, ma'am. Yeah.
could share your screen? So, yeah, thank you. Okay. Manohar sir, can you unmute your mic, please? So, can you please unmute your mic? Manohar sir? Okay, so there's some confusion here. I believe.
Hello, ma'am.
Yeah, you said you completed your circuit,
Yes,
sir?
yes, ma'am. Yeah.
We
Are you
cannot.
able to?
No, sir. So when you go to presenting screen, you have to click on present window because we can see only one tab of your Chrome. So can you represent it? When you present, click on share window, sir, not just a tab.
Okay.
You get a window option, no? So click on that and then click on that window and then share.
Now?
Yes, sir. Now we can see.
Yeah.
So this is the, yeah. So,
Yes,
okay.
ma'am.
This is my earlier experiment. Yes, sir.
This
So
amplifier has been designed for a voltage gain of 10, ma'am. This is an inverting amplifier.
yes, sir.
So I have given the input as 0.2 volts peak to peak,
Mm-hmm.
and I'm getting 2 volts output. That
So
is
yeah.
this is the input waveform.
Yes, sir.
Whose amplitude is 0.2 volts peak to peak, and I'm getting an inverted sine wave of amplitude 2 volts peak to peak, because the gain that I have set for the amplifier is 10.
Yes, sir.
Because the voltage gain is 1000 by 10k.
Yes, sir. So
Yeah, 1000 ohms by 100 ohms. Yeah, that is 100k by 10k. 100 by k 10. 100k by 10k. That is 10.
okay. Yes, sir. So this is what I was about to show because of some network issues. Mine I couldn't show the waveform. The circuit is same as you can see, but yeah, the waveform was not shown. So, sir, if you could switch off this one simulation.
Hello, madam.
Yeah,
Hello.
one point I would just like to say is, sir, if you could click on move.
Hello, madam.
So 1
Yes.
minute, sir, I'll complete this. Sorry about that. And click on any component there.
Yes, ma'am.
You can move it in the workspace. That is what I did not mention. So if there is any wrong, when you select the component and place it in a wrong place, you can move it. Just click on the move and yeah. So that is one thing I forgot to mention. So thank you for that, sir. And also I believe that output part was shown. So now that it is clear, so you can stop sharing your screen. Thank you so much, sir.
Hello,
Yes,
madam.
sir. Vijay, sir.
Thank you,
Yes.
ma'am.
Thank you, sir. Vijay, sir.
Hello, madam. Actually, that what you have given the input, no, the input and output frequency should be same, but it is different showing actually.
This is technical details that you're talking about, no, sir?
Yes, madam.
Yes, sir. That maybe after looking into the lab experiment, we'll have to know, sir. Maybe if that is an issue, like if there is a technical problem, you can always raise a feedback there, because the developers will make the necessary changes so that labs will perform quickly. Thank you, sir. So, okay, Manohar sir, can you mute your mic? Thank you. So now I'll move on to one more lab, that is from electrical land. I'll present my screen. So yeah. So I'll present one of the electrical labs. So same thing as we did for EC, we'll go to this area and select for electrical engineering. So I've selected electrical engineering. Close this. Yeah. So I'll take you to one of the electrical machines lab developed by IIT Roorkee. So this will be my, and similar to that, we have an introduction, we have objectives, we have list of experiments. And under this, we have 8 experiments currently live. So I'll take you to one of the experiments to perform speed control of DC motor by using Watt-Leonard method of speed control. So click on that, and I've already opened the page. So this is how it looks. This is my simulation page. Just to avoid all the network issues, I kept this page open. So here again, we have theory behind the same experiment. Then we have pretest procedure. Procedure is one thing you will have to note down carefully here, because there are a lot of connections related to this as in our lab. So once even here, this is our workspace. This is when I click the simulation, it will take me to this page. This is my workspace, and we have an instructions here. I'll just zoom out my page just until I make the connections, so that the instruction is also visible to everyone. So now we have an instructions. So all the connections is shown here in the instruction page. So it says that connect A1, B1, C1 of M. No, okay. So since I made a wrong connection, I'll just click on that C1 node to remove that connection. So that is done. Now these things you have to follow the instructions. So even to, you just click on the click on one node and drag the cable to the other node where you are going to make the connections. So that is done. D1 to D2, H1 to H2, and H1 to I1. J1 to J2, J1 to I2. I2, K1 to K2, K2, K1 to L1, L1, L1 to L2, 1 to K1 to M1. M1 to M1, N2 to O1. Missed one, K1 to K2 connection here. So this should complete my connection. This is stated even in the instruction part, which I have already done. So now switch on the MCB. So I'll have to click on check connections. This is similar to all the experiments. So you have to click on check connections to check whether your connections are right. And it says that correct connections, proceed to the reading. So similar to basic electronics lab, if you do make a mistake in the connection, click on that node or the point where there's an underline. You can see that. I'll show it later on. Now I'll just go with the flow, and I'll click on check connection. If the connections are not correct, yeah. If the turn on the MCB. So I'll switch on the MCB here. Click here, and MCB will switch on DC supply as well as the starter. Now the instruction says that double click on auto transformer. So this is the auto transformer. We'll just double click and we can see that the voltmeter as well as the generator induction motor. So now I'll just zoom in the page. Okay, I cannot do that. So here, if you can see, okay, just to make it clear, I'm zooming it. So here we can see that there is one scroller here in the DC generator field resistance. So this, when we slide, it controls the speed of the DC motor. So here I'll just slide it, and the DC motor, you can see the voltmeter as well as speed of the motor has been changed. Now click on add values. Similar, this is similar to all the experiments here, and the value is loaded here. So one feature about this lab is when we add value, the graph is live here. So every time you add value, the graph will be updated. So again, you change vary the value and add value. So I'll just keep on increasing the value and take some 5 to 6 values just to get a clear picture. So this is how the graph is. This is a live graph. Again, we can here too, we can click on print page and it will print take you to the print. Same thing. Shows us how to print the print page, which can be submitted as an assignment by the students if required. So this is it is taking little while to load the preview. So yeah, this is our print page, and this is the submissions. So even the graph is included here. I'll just cancel it. So one point that I've already mentioned is, one is you can click on those nodes. Since there are many connections here, to remove one node connection, you just have to click on the node. So I'll just click on K1 and all the connections related to that K1 disappears. Click here to switch off. So I hope this makes it clear for the people. And I want one of the participants to present their screen. I'll just stop sharing the screen now. So I request one of the participants to present their screen and select one of the experiments in this lab.
Madam, actually, speedometer measures it in the real lab, but in virtual, how it will be visualized? We are getting a visual. But what is it is doing to get that speed is more concerned. In a real lab, we use the speedometer, tachometer.
So there's many noise. I cannot hear your query.
It is regarding the speedometer measurement.
Yes, sir.
That speedometer measurement we do in actual lab with the help of tachometer or a speedometer.
Yes, sir.
But in virtual lab, we'll get an indication, that's it. I don't know how we are going to, we have to sense it now.
Yeah, the values, that is...
what we get in the value, how it has been theorized is the issue here.
One thing is, we already had of lab. One is measurement based and another one is mathematical equation based or simulation based lab. So this is one of those type of lab where the, okay, I'll finish this. So one is measurement based labs is where the real time data is, like in your actual lab, we get the data as you mentioned, you collect the data. So those data sets will be taken and used to develop the program and develop a virtual lab. And then there is one more simple equations considering um, all the variables as constant or ideal condition, and the data are shown like that. This is also that is how the values are generated for the speedometer, sir.
Okay. Thank you, madam.
Thank you, sir. Okay, Shravan sir is presenting. So there are like two people presenting, I think. So who, Hemant sir is presenting.
Yeah. Is anybody else presenting?
It's Shravan sir, but I think you can continue. But yes, sir.
If he wants to, I will exit. Not an issue.
He has exited already. So
Yeah, ma'am. Which experiment shall I execute?
so okay, yeah. I
Yeah, thank you so much, sir.
any of one of the experiment maybe a load characteristic of DC shunt generator or
In the procedure, we'll get a circuit, right?
yeah. So even in the procedure, you can see if you make a wrong connection. Even in the procedure, they have shown a final image of all the just to make it easier for the students to understand, and if they could, so you can go.
Yeah, I think it's screen visible.
Yes, sir. Yeah.
So I'm making connections.
So I'll just answer Vijayalakshmi ma'am's question that how to do undo single connection. Whichever node you are selecting, click on those nodes, and it will let you undo the connections now.
Hemant sir, you share the screen, sir.
I think screen is shared.
Yes, we can see your screen.
Yeah. 2 seconds. I think I'm done with the connection. Yeah. So we need to check that one, right? After doing connections. Correct connections, it's showing. Okay. Ma'am, it's showing both. Connection is right, connection is wrong, something like that. Shraddha ma'am? Can you hear ma'am?
Hemant sir, I think ma'am has left.
Okay.
Sir, I think you have to select the bulbs.
So I'm selecting, sir. Yeah,
No, sir. Number of bulbs it is there, no, sir, in that left side. Yeah, there, sir. Yeah. Please click it, sir.
Okay.
Yeah, you have to select the bulb. Yeah.
Fine. We are getting, sir. Thank you.
We're getting okay.
You can just check the graph, sir.
Yeah, 1 second, sir. I will take 2 to 3 readings, then I will check with the graph. Yeah, graph.
Yes.
For minimum 6 readings are required to plot a graph. It's showing. Yeah, it's showing, sir. Minimum
Yes, sir.
6
Thank you.
readings we need to take.
Yeah, thank you, sir.
Yeah, thank you.
Yeah. So is my voice is clear and audible now?
Yes,
ma'am.
Okay. Shraddha ma'am, are you back? Okay, I think there is some system issue. No problem. Let me continue. So, very good afternoon to one and all present over here. Myself again, Shrestha. I am back over here. So, let me present my screen now. Okay, hope my screen is also visible. Yeah. Okay. It is not visible.
It is visible, ma'am.
Okay, sir. Thank you. Fine. So, if you see the list, you can see there are many more labs on logic design and so on. So, for example, digital electronics lab, digital logic design lab, hybrid electronics lab, digital electronic circuits lab, everything deals with the concepts of digital electronics subject. Also, we have many more labs on this particular topic in the new lab development side. Okay, so let us see now one of them. So let me take you with hybrid electron. To start with, I'll take you with hybrid electronics lab from COE Pune. Okay, so this is one of the very basic lab we have for digital electronics subject. Okay, so here are so these many experiments are available in this particular lab. So let me take you with one of them. So this is again the simplest one, the implementation of arithmetic circuits. So basically, when we say arithmetic, it is adder, subtractor, and other things. Okay, so when we have digital electronics lab in the physical lab, when we consider what we do, we take a trainer kit, we connect IC, we do the connection, we provide input and observe the output and verify it with truth table. This is what the procedure is. Similarly, over here as well, the other content covered is same. I'll directly move to simulator. So click here for simulator. So the experiments under this particular lab will have this kind of interface. So the simulator interface is in this way. So here no need to do any of the connections. Only we need to provide the input, click on the run button, observe the output and compare it with the truth table. Okay, so when we say adder, we have 3 variations. All the 3 will follow similar order. When we say subtractor, again there are 2. One is half subtractor and one is full. Again the procedure is same. Provide the input, click on the run button. We'll be getting the output. Observe it with the truth table, verify it using the truth table. Yeah, so we have 4-bit adder subtractor circuit as well. So this could be used as a classroom activity. So after explaining the concept of 4-bit adder subtractor, we can give student the problem and ask them to solve using pen and paper, and the answer could be verified by coming over here. So these answers will be the verified ones. So we can provide the input, click on the run button, we'll be getting the appropriate output. Fine. So this is one of the simplest interface that is available when we say logic design or digital electronics subject. So similarly, when we hybrid electronics lab, under the list, we have experiments for code converters, counters, shift registers, ALU, and so on. So to look into one more experiment, say let me go into arithmetic and logic unit or ALU experiment. So can I, no, let me only go within that. Okay, so again, I'll go to simulator, click here for simulator. So the simulator interface looks similar. So here we have arithmetic and logic operations. Yes. Okay, so we have arithmetic as well as logic variation. So in arithmetic, we have mode signal as 1, and in logic, we have mode signal as 1, and in arithmetic, we have mode signal as 0. Here we cannot change the mode bit. Yeah, it is fixed since here only is the division, and here are the input and the select lines given. So we can change these select lines and the inputs accordingly, and by clicking on the run button, we can get the output and observe it using the truth table. Yes, so this is with respect to ALU operations. So we have totally 32 arithmetic operations being listed over here for 4-bit select lines, and also we have 16 logic operations that have been detailed in the truth table. Yes, so to move next,
Can we
in
do
the
a stable and monostable multivator? 555 in that hybrid.
okay, got it, sir. Shall we have it later on? So I think monostable experiment, let me show you with one more lab.
Okay. Okay, no
Yeah,
issue.
so yes, sir. Fine. So that is with respect to the so to move next, let me take you with digital electronic circuits lab from IIT Kharagpur to demonstrate a different type of interface that is available. Okay, so here let me go within list of experiments. So these are the experiments available over here. So here again we have experiments for decoders, multiplexers, logic gates, and so on. Okay, so let me go with the eighth experiment I'll take you with, that is analysis of flip-flops. Okay, so we have again introduction to this particular experiment theory. So here different types of flip-flops have been discussed. So we'll be seeing the demonstration for 3 different types, that is SR, JK, and D. Then as the objective procedure to do the experiment over here. Then as the simulator. So here you can see part 1, part 2, part 3, and part 4. So there are 4 parts, each detailing one type of flip-flop. Then are the quizzes, that is set of questions to test our understanding. Then are the reference links. Okay, so I'll go back to the simulator. This again works with Adobe Flash Player. So I have already enabled it. Once we enable Adobe Flash Player, this is how the simulator interface looks like. Here again, we need not do the connection. We have 2 ICs given. We have 2 ICs given. So we know when we have IC, we have to provide VCC and ground. So first step would be that according to the procedure if we follow. So here is a portion where we can observe the waveform. Here is a portion of simulator where we can provide input, and this is to observe the LED outputs. Okay, so to observe the outputs through LED basically. So what are the steps to follow? So basically, as I told, to start with, we need to provide VCC and ground. We have 2 ICs. So 2 VCC, that is VCC1 and VCC2. So first I need to enable that. I need to click on it. Yeah. So once I enable both VCC1 and VCC2, I'll keep in 0 state. I'll be getting access to this clock start button. Before that, before enabling VCC1 and 2, we will not get access to this clock start button. So if we click on clock start button now, you can see clocks running. So I'll stop the clock temporarily. Then here, there is something called number of clock pulses. What is that? So here we can give numbers, say for around 4 or 5 I'll give a number as 4. So for these many clock cycles, I can observe the output for each combination of input. Then the execution stops. Okay. So for each combination of input, we can observe the output for these many clock cycles. Then the execution stops. So the flow is, if I want to implement set condition, I have to enable S. I have to turn it. Then I need to click on clock start button. You can see clock cycles. Q has turned to one stage. Then the execution stopped. We can see the output over here as well. Similarly, we can observe other conditions as well. We can, if you want to implement reset conditions, provide the input, click on clock start button. For these many clock cycles, we can observe the output. Okay. So this is how flip-flop demonstration has been done in this particular lab. Okay. So now let me stop sharing my screen. Can we have one of the participants doing one of the lab from
Can
this
we
particular
have
lab?
what we call this as master slave JK, where race conditions can be demonstrated? JK flip flop master slave,
Yes,
where
sir.
race conditions can be demonstrated. Race around condition, because race around condition is a bothering in JK flip flop.
Okay.
Consider a master and a slave, and we need to enable the students on that. Can we have a demonstration of it? Please demonstrate, or how any participants can demonstrate, or can you do with the participants, or what is the way?
Yeah, sure, sir. Actually, race around condition, I don't know if they have taken care of that over here. They might be. So I think
That is a botheration in digital, because that's what the things are in digital. The race around condition is important.
yeah. So I think one of the participant can take that. If not, you can do with the other experiment demonstration. Meanwhile, I can look into that, sir. So can one of the participants share your screen and do the demonstration on one of the experiment under digital electronic circuits lab? Hello. Can we have one of the participants sharing their screen?
Yes, ma'am. I am just going to show.
Okay, there is, yeah. Hello. Yes, sir. You can share your screen.
Is it visible,
sure.
ma'am?
Yes, sir.
Just
Maybe you can take one of the other experiment.
other experiment. Okay.
Yeah. In the same lab.
Okay. Digital electronic circuits.
Yes. Maybe you can take the experiment on shift.
I have enabled, ma'am.
Yeah.
Then this I need to enable switch.
Yes. So you can keep that initially with 0 state only.
Okay.
So if S is 0, serial in serial output will be demonstrated. If the mode control bit is 1, parallel in parallel out will be
Ma'am, one more
demonstrated.
clock start is disabled. Why?
Yeah. So if S is, yes, sir. At a time, only one clock will be enabled. So we have two separate clocks to demonstrate two of the shift registers.
Can I start now?
Yes, sir. You can stop the clock temporarily.
Yes.
Stop the clock. Yeah, now you can enter the number over there.
Yes.
Say just enter 1. That would be
1.
better for, yeah.
Okay.
Now you can give the data bit as high.
Yes, here.
Yes. No, that is, no. Disable that, sir. Disable
Okay.
S bit.
This data, DS.
DS, yeah. So now if you click on clock start button,
Yes. Data
you
bit is
can,
coming as high.
yeah. So now if you change the data bit also, the same thing will propagate. So basically the changes are taking place in a negative edge of the clock.
Yes.
Meanwhile, in middle, if you change the data bit, the initial data only will be propagating since this is serial in, serial out.
Yes, ma'am.
Yes. So if you want to now demonstrate the parallel in, parallel out shift register, then S bit has to be enabled.
Here. Okay.
Yeah. So once you enable S bit, you will get the control for clock start button. That is second clock start button. You can give parallel data, P0 to P3 data. You can give according to your wish. And if you click on the clock start button, second clock start button, you can see the output accordingly.
Yes, ma'am. It's coming.
Yeah.
Thank you, ma'am.
Yes, sir. Thank you, sir. Fine. So let me share my screen now. Yeah, hope my screen is visible. So we will go with the next lab. So let me now take you with the digital signal processing lab from IIT Kharagpur, that is DSP lab. Yeah. So here again the content covered are similar. So the list of experiments. So these are the experiments available under DSP lab currently. Okay. So let me see one of them. So I'll take with first one only, demonstration of sampling theorem. So we have introduction, theory, procedure, everything with respect to this. So we have introduction for sampling theorem experiment, theory detailing the concept, then is the procedure to perform the experiment over here, then is the simulator, then other quizzes and references. So here if you look into the simulator, it is the procedure is given in step by step manner, and the interface is something like this. This again works with Adobe Flash Player, so you need to enable that before using the simulator. Okay, so first thing is we need to click on browse blocks button. We need to now place all these 3 blocks over here on the workspace. Okay, unlike what we write code in the physical lab, this is provided in a blockwise manner. So here we can give the specification. So I'll give 4 volt as amplitude, frequency say 10. This specifications we can change it later on as well. So we have generated block, we have sampling block. So here we can give the sampling frequency, say 30. I'll give 30 kilohertz as a sampling frequency, which I can change later on as well. Then is the virtual scope block. This is to observe the output. Okay, so these 3 blocks are available now currently. Next step is we need to connect all the blocks. Yeah, so according to the procedure, if we follow, we need to connect generator block to the sampling block. If the connection is complete, it will be shown in red color. It will be shown in black color. If the connection is not complete, it will be shown in red color. Okay. So if the connection goes wrong, then we can click on undo button and redo the connection. Here the undo button is available. So if we click on that, one step or one connection goes off. Yeah. So once we are done with the connection, we can click on virtual scope block to observe the output. Yeah. So this is how we have the output window available. So we can change the specification over here according to our requirement and observe different cases of sampling. Yeah, we can change the sampling frequency as well. We can change the phase. And this is how we will be getting the output. Here we can see the value of y of n for each value of n. Yeah. So here at the bottom, we can drag this and see y of n for each n value. Yeah. So this is how the experiments under DSP lab will have a interface in this virtual labs platform. So all the most of the experiments will be blockwise only. So I'll stop sharing my screen. Can anybody present one of the other experiment in DSP? Can one of the participants share your screen and demonstrate any one of the experiment in digital signal processing lab?
Ma'am, can you please once again tell that earlier experiment?
Yes, sir.
That I got stuck in that simulation part.
You are stuck in that simulation part. You are not able to move through.
Yes, ma'am.
Okay. Yeah, before that, there are many questions with respect to VLSI lab with the demonstration of that. So there are two labs available for VLSI in virtual lab platform. One is under electronics and communication domain and one more is under computer science and engineering domain. So the lab under electronics and communication VLSI lab is based on NG Spice. So currently actually it is under some modifications. So today it is not accessible. I request you to try maybe in 2 days later or so. And even then, if it is not working, then you can write to us. And one more VLSI lab is under maintenance. So if required, I can paste the link of VLSI lab over here. There are two labs relating to VLSI. And HDL lab, currently there is no lab with respect to HDL, ma'am.
Oh my God.
Yeah, so
Can I share the screen on that FFT transforms and show that, present
yes.
that?
Yes, sir. Yeah. So before that, just a second. So I think Manjunath sir had it out, right? Are you in a flow with this one, sir? Experiment?
Yeah, I am in flow with the experiment. If you
No, sir. One second. At that time, okay. I think Manjunath sir has some network issue. Fine. You can proceed, sir. You can share your screen.
Yeah, madam. 1 minute.
Yeah.
I'm able to share the screen. 1 minute. Is screen visible for you? No.
No, sir. You need to click on present now option.
Yeah, madam. Yeah.
And a window.
Somewhere there is a problem. 1 minute, madam.
Yes.
I think now is it visible?
Yes, sir. Yeah.
Yeah. So now I'm going to lab now. 1 minute. This is the screen which I have shared. Here here, this is what is the FFT things which is there in the simulator. So there are some introduction theory procedure, and now I have selected the simulator. So here input signal is the rectangle we are going to select. We have ramp and sinusoid also. So rectangle we have selected, and we can select the number of samples now. That is what, is it not? Hello?
Yes, sir.
So then we can have this DFT points. We can have the DFT points here. Is it not? So that's what the things are. And so the simulation will begin, or how to begin the simulation, I'm not getting it. So I think, yeah. So can I click once again on the simulator and refresh it?
Yes, sir.
Yeah. So this is a simulator which we are seeing, and in this simulator we are selecting the points here. Then these are all the DFT. So now, if a signal after inverse DFT, see if, for example, what I am now getting is this is a signal at the input voltage. Now we are doing the signal after applying DFT. What after applying DFT, these are all the things. The phase spectrum of the signal after applying DFT is graph 3. And once we take IFFT, IDFT, in the sense discrete Fourier transform, the same signal we. No, but the frequency here, the things will vary. I hope so. So this could be the things of DFT, IFT, this one.
Hello.
Is this graph 1? Graph 1 is this one. This one only, I think. Is it not, madam? I don't know what is the thing here. Hello. Yeah.
Can you show it the first experiment once again in the DSP lab? What you shown?
Yes, sir. Yeah, I was showing on the same thing. So we go for list of experiments. Here I selected what we call that as DFT, and we go for list of experiments. Here I selected what we call that as DFT, and it's a study of discrete Fourier. Simulate the things, picking the number of samples and DFT points if I pick up. So this is what the waveforms we are getting. After applying DFT, what are the things what we are getting is this. And phase spectrums, we have both amplitude and phase. And then after inverse DFT, we are going to get the same points. So, but theoretically, we have to map this with the practical things what we are going to get. So that's how the things are. I hope so. Is it not?
Thank you, sir. That sampling theorem. Can you once again explain sampling theorem? First experiment.
Sampling theorem. Let me try, sir. Let me try.
Yes.
Oh, yeah. So we have yeah. So list of experiments. We have to go for list of experiments now. Yeah. Sampling theorem. Yeah. It's loading. There are some networking problems. But the sampling theorem, I am not getting it, sir. There is some networking issues.
Hello.
Hello. The sampling theorem.
Yes, sir. Actually, there was some network issue, so I had the page put out.
Yeah, okay. Sampling theorem, and still there is some problem in the. Yeah, this is
okay.
This is a simulator.
Yes, sir.
We are getting it. This is a simulator. Then we have to browse blocks. I think.
Yes, sir. Yeah.
We have to browse the blocks. Signal generator we need to pick, no?
Yes, sir. All the blocks you need to get into the workspace.
Okay. So we have to place it and see the.
Yes, sir.
So some.
give the specification.
Okay. So some 4 samples, let me give. Okay.
No, it is okay. Fine. Some random value you can give, sir. Which you can change it later on
This
as
is
well.
sampling block. And this is the sync generator. This is the
Sine wave generator.
Okay, but I'm not able to pick it up.
You need to click on that. No, just click on the sine generator block.
Okay.
Yeah. Now
Drag
get
it.
it on the workspace.
Okay.
Yes, sir. No, just get it. Move. You need not click on that.
Okay.
Just place it over there.
Okay. Amplitude.
Click over there, sir. Yeah.
We have to give some amplitude, some 4 volts or 5 volts. Frequency, we can give some 50 hertz or so.
Yeah. Maybe you can give 1 or so.
Okay, 1.
1.
Can I
No, you have
present
given sampling frequency as 3 kilohertz.
3. Okay. So my problem is this.
Can I present it, madam, if you don't mind? I mean, if Krishna sir also don't mind.
Phase angle.
Yeah. So
phase angle, is it necessary? No need, no?
not required, sir. Not required.
Okay. Yeah. So then virtual scope. Is it no? And we have to. So yeah, we have to connect the blocks. Is it?
Yes, sir.
So from
now you need to connect all the blocks. Yeah.
This.
Yeah. Click over there. Click over there, and yeah.
But we are not getting it.
So can I present it if you don't mind?
Yeah.
Let me define the amplitude as let's say 5 volts and the frequency as 1 kilohertz. Let me take the sampling block, choose a sampling frequency exactly equal to the Nyquist rate, and then choose the then place the virtual scope. Then start doing the connections. Done with the first one, done with the second one, and I'm supposed to do the connection between the sine block and the scope. And that's it. I don't think it happened. Okay.
You can undo the connection. Yeah, you can click on some empty space, sir. You can click over there. Move up. No, somewhere move up. You need not connect directly. It need not be a single connection. Yeah, click over there.
Done. Now done. I'm done with it.
Yes, sir.
Now if you try to just double click on the scope, you'll be able to see this.
Yes, sir.
I hope you're able to see, all of you. Now I can just make the changes for this FC and I can see the sampling output coming. I can think of increasing this, and I can see only 2 samples for many number of input cycles, which is kind of undersampling, of having oversampled wave. So things could be visualized like this with different amplitude values as well. Kind of good. It's kind of good for students as well. You know, they'll enjoy it because visualizing becomes very easy for them.
Thank you, sir.
Yeah.
My question is, see, it's very good for students to get this GUI based simulation, but what about coding? It's also very, very important to get the output. That's igniting the students to think about the coding. So coding is also important. My suggestion is to get to improve this simulation, not only GUI based, they need to give a small space for coding. If you write code and then if you press execute, then it should take that execution and present it in GUI, like in MATLAB. My suggestion. Thank you, sir.
Is there in VLSL lab? Verilog code it is taking. I simulated just now. I checked. You can paste Verilog code with the test bench model. You can simulate. It is there in VLSL lab, sir.
VLSL lab is working currently.
Yeah, it is just I checked. Because of syntax errors, I not got the output.
Okay, sir. Which link you have used, sir? VLSL lab in?
VLSL lab.
Under virtual lab platform?
Virtual
Okay. Can you then share your screen, sir? Because at that time the VLSI lab was currently down.
Yeah, I'll show that, madam.
With the simulator.
I'll show just now, madam. Home.
Yeah, the voice is not that clearly audible.
Home. So, the home. Prod area, electronics and communications.
You can you share your
Yeah, so in this VLSI lab, I take.
sir, your yeah, it is loading.
Yeah.
Yes, sir.
VLSI lab. Just I taken somewhere here only. VLSI lab. This, maybe I went here, madam. Lab development. Explore labs. Development. Yeah, here I checked, madam. VLSI lab. Somewhere. Taken. VLSI, maybe I don't know. I forgotten the link. Just morning I checked. Here, computer science. How to go to computer science, madam?
You can come back.
Yeah.
No, you can just come back.
Science, no?
Yeah.
Home computer science. Yeah. Yeah, here I checked. Maybe probably. Yeah, here is there. VLSI lab. Okay, list of experiments. Yeah, just went with the. Just one I checked. Code, spice code and logic multiplexer. Simulation. Yeah. Yeah, click here for the experiment. It is asked Verilog code. I pasted with the test bench model. But because of error, I am unable to see the output.
Okay, sir. No problem.
Yeah, it is taking time, madam. It is not loading. Maybe server is down.
That's okay then. Actually, at that, no problem, sir.
Yes, here it is.
Yeah,
there.
you can unshare, stop sharing your screen as well. So at that time, people were, yeah. Sir.
Yeah, I stopped sharing.
Yeah, thank you, sir. So yes, so is DSP lab sampling theorem or so other experiments? I think hope it's clear with everyone. That time somebody was stuck with the connections or so. So hope it is clear now. Let me share.
Connections, how we connect that sampler and sinusoidal, I'm not getting it.
Should I present it once again, sir?
Yeah, please once, can we show the
Yeah, I'll do one thing. I'll present one more this experiment.
There the connections.
Yes, sir. One more similar experiment. Let's go on with. Yeah.
Now I got that window, madam. Verilog, shall I show, madam?
Yeah, sure, sir.
Yeah, I'll share that window. Just I'll present that. Yeah, here. Can you see my screen, madam?
Yes, sir.
Yeah, here it is coding part is there in this. So you can paste this, copy this. This is source code for OR gate. So you can paste it, simulate. So if you simulate with the code is incorrect. Suppose if you write properly code, it will come with the test bench model because you have to call the design block in the test bench model properly. Here mapping problem is there. That's why I am not getting the output. It is there, madam, coding. Okay.
Yeah, so as I already told, there are two labs based on VLSI in virtual lab platform. So one is under computer science and one more is under electronics domain. So please check it at that time. So requesting it to check at a later point of time, and even then if it is not working, you can write to us. Okay, so let me quickly present one more experiment under lab with a similar setup. So hope my screen is visible now. I'll go with digital signal processing lab, list of experiments. So let us take second example now. So I'll go to simulator. So this also have a similar simulator, sir. So we need to click on browse blocks first. We need to get all the blocks and place it over here. We need to give the specification. So according to the procedure, if we follow, next step would be virtual scope. Next is quantization block. So say I'll give 4 or so. Now next is to connect all the blocks. So connecting is when we take the cursor near to the block, it will show a pen mark. So we need to click on that, and then we need to go to the other block. We need not click and drag. No, just click over here, move your pointer and click on the next block. It will be connected. If the connection is showing black in color, then it is connected. If not, the connection is incomplete. So just click on one end of the one block and take the cursor and just click on the other side.
Okay.
Now it is not connected. So I'll undo the connection. So sampling block and virtual scope. Now it is complete. So basically we need not click and drag the things. No, we need to click at one end, remove the pointer, just go to one more block and click one more time over there.
Okay, okay.
So hope it is clear now.
Okay, okay. Okay, thank you, madam.
Yes, sir. So I think to move on, the next connection would be this thing. Then connecting the quantization block to the virtual scope, then input to the virtual scope block. So this is the connection. Now we can click on virtual scope block to observe the waveforms. Yes. So hope this is clear. So let's move on. So now let me quickly show you one more lab, maybe in the new lab development side on yes. So I'm into new lab development site now. So under explore labs, as already told, we have two approved labs and labs under development. So let me go into labs under development now. So let us see one of the lab over here on analog electronics. Okay. So here are the list of experiments. Other contents are similar. So these are the experiments available under analog electronics. New lab development button in the main website. Then under new lab development, it is when we click explore labs, it is under labs under development. We will be getting analog electronics lab. Under this, these are the different experiments available. Yeah. So here let me take with astable and monostable multivibrator experiment. So at that time, there was a query regarding this particular experiment, I suppose, in one of the labs. So again, the experiment is available over here as well using IC555. So the content covered is same. So it is aim, theory, pretest, procedure, other things. So I'll go to simulation now. Yeah. So here we have two options. One is astable multivibrator and one more is monostable multivibrator. And if we go within that, this is how is the simulator available for this particular experiment or for the experiments under this particular lab, that is analog electronics lab. This is the simulator interface. Okay. So here we have procedure given in this way. So we need to do the connections, then check if it is right, then vary the resistance, calculate pulse width, then observe the waveforms in the graph area, then we need to update the table, then we need to take the readings. Yeah. So accordingly, if we follow, here the connection involved is only input and output. So we need to connect input. So here we need to click on the terminals and drag. Okay, in DSP we just need to click at the endpoints, but here we need to click on the terminals, drag the cursor and place it on the other terminal. Yeah. So now we need to connect output to the graph area. Yeah. So this is the connection what they have told in the procedure. Other connections are already done. Next step is to check if the connections are right. Yeah. So once we have the right connection, we can move forward. So here we need to provide input resistance in steps. So with each value of resistance, we can click on calculate button, and then we'll be getting the pulse width for this particular value of capacitance. Then if we click on add to table, the table getting updated. So we can take some 5 to 6 readings, note down the variation in the graph. So this is how the experiments have the simulator interface under analog electronics lab. Yeah. So hope this is clear how it goes. So I have stopped sharing my screen. Is the flow was clear?
Hello, ma'am.
Yes, ma'am. Yeah, good afternoon.
Good afternoon, ma'am. Ma'am,
Yes,
how about the VLSI lab, ma'am? Like, we're getting error with respect to that when we execute the code which is given itself.
There actually for
How
me
to
the
do with
simulator
that?
is not accessible currently. So is the that's what I thought. I saw one of the participants only getting doing the demonstration. Before that, when I tried, it
Yeah,
was
yes.
not visible. Yeah. So can you write your own code? Is that is possible?
I tried my own
Yeah,
code.
if you try with
Again,
your own phone. Yeah, same
Try
problem.
writing your own.
even though I written correctly now without any errors, I written simple half-added
Okay.
code. So I'll share the screen.
Okay.
What I written.
Okay.
Is there any Java installment something is
See,
required
madam.
for that, ma'am?
See, this is the code what I written half-adder.
Okay.
That half-adder I'm
Okay.
calling in test bench. This is I written one. Okay. I'm trying, but it is just if we simulate, it's showing code is incorrect, but my code is correct only. There is no errors in this.
Okay, then I think there is some updation going on because for me the simulator is not accessible. So it is with time it is varying. So please wait, maybe within a week or so, have a look. So there are many requests on VLSI lab. So everyone, please look into maybe within 1 week, after 1 week or so. If the error persists, then you can write to us. Okay, I'll be sharing mail ID in the chat box, so you can write to us. So I think with this, I'll stop presentation from my end as well. So that's what on VLSI, 2 labs currently. HDL, there are no labs, and communication, there are no labs currently yet to be developed, sir. So with this advanced communication or digital communication, currently there is no lab available. DSD writing code is not available, but that's what the concepts are there.
But what about
Basically on logic design? Yes, sir.
optical communication?
Optical communication, there are a couple of labs available in the physical sciences domain. So these are few of the labs that we demonstrated. I think we are now towards the end of the session. So I think the rest of the labs, I request the participants to explore. So please explore the different labs available. So there are many more labs available. So when we say, so I'd like to conclude. Basically, then I would hand over the session to Narsimurthy sir from SIT Tumkur. I'd take 2 minutes. 2 more minutes. So to conclude the session, the labs relating to electronics or electrical, basically circuit domain in virtual lab platform, the areas where you need to look into is one is electronics and communication domain, one more is computer science and engineering domain, one more is electrical engineering domain, and labs under new lab development portal. These are the 4 points, and one more is under physical sciences domain. Okay, under physical sciences domain as well, there are a couple of labs for optical fiber related topics. Also, there are some labs that is solid state physics lab, which details the concepts of electronics. Okay. So BH curve, Zener diodes, and all have been explained in that particular lab as well under physical sciences solid state physics lab. So these are few of the variations we will be getting the different concepts of electronics being explained in virtual labs platform. So other than that, I request all the participants to explore the different labs available in different domains under this virtual lab platform and pick whichever suitable for you. Power electronics lab that is available in the new lab development site, I think. That, currently, there is only one experiment available under power electronics lab yet to be updated. It is under labs under development site. So I think with this, I'll conclude the session from my end and hand over the session to Narsimurthy sir. So over to you, sir.
Thank you so much, madam. So
Yes,
let me just present. Okay, I have very few slides, and then immediately after that, I go for the demonstration of.
Yeah, so basically SIT Tumkur is one of the nodal center of NITK Surathkal under this virtual lab platform. So it is one of the very active nodal centers. So the students from SIT Tumkur had come to NITK Surathkal during vacation time and pursued their internship in NITK Surathkal and contributed in the development of labs as well. So it is one example where other nodal centers also can involve in the development as well as in the outreach. So with this, I would like to hand over the session to Narsimurthy sir. So he will be demonstrating you how they have been associated being nodal centers with virtual labs and with virtual lab project basically. So over to you, Narsimurthy sir. So we'll be having this session up to 4:15. Then the session will end. Thank you.
Yeah, 1 second, madam. Okay, I'm able to share my screen. Present now. It is. You must grant permission in order to share the screen. So you cannot share the screen. I'm getting. Are you supposed to give any permission over there, madam? Yeah, I'm just doing the same. I'm just doing the same. Voice is fine now. Yeah. So let me just, make sure that, is my PPT visible? Hello? Hello? Hello?
Sir, it is uploading, sir.
Yeah. Am I audible?
Yes, sir.
Yeah, fine. So, one of the things is respond, is it visible or not, so that I can start the presentation and then. Hello?
Sir, the presentation is not still uploaded.
Yeah.
Is not shared.
Voice is not clear, sir.
Maybe for a few of the voice is not clear, whether it is same with all of you.
No, sir. Voice is not clear, sir.
me just check it out. Is the PPT visible slides?
No, sir.
Voice is not clear, no.
Presentation is not visible, sir.
Okay, I'm just taking some time.
No, we are not able to hear you, sir.
Okay.
Share the screen, sir. Screen is not shared, I think, sir.
No, it has been shared.
Sir, you need to click on present now option.
Madam, already done that.
So when you click on present now option, you need to click on a window.
Yeah, that I'm doing.
Okay. And then you need to click on the window you want to share and click on share button.
Yeah, that's what I did all those things. Let me just do it again.
Click on present now option, then on a window.
Yeah, fine. Now?
Then
Use the
you
present
need to
option,
click
sir.
on the... Yes, sir. It is coming
Yes,
now.
yes.
Yeah, fine.
Now it is coming, sir.
Yeah, fine. Okay.
Yeah, your voice can be a bit louder, sir.
Yeah, I
Be little louder, sir.
Yeah, fine. Okay, thank you, VTU, for giving me an opportunity to share the experiences that we have obtained during the development and usage of this remote laboratory. So myself, Dr. K.
Slide is not visible, sir.
Okay, is slide
Hello?
not visible to all?
Slide is not visible, sir.
Hello? Hello? Madam, is the slide not visible?
Not visible, sir.
No, sir, not visible.
Visible, sir.
I'm not interested in. Slide is not visible, sir. So I'm taking from the round.
One second, I will do it. Is it now visible? Hello?
No, sir. No, sir, no.
Okay. One second, let me just try it out again.
Hello?
Hello? Over now.
Nothing is visible, sir.
I'm trying to share the same slides.
Hello?
Over now? No.
We are not able to see the presentation, sir.
Sir, after sharing present now,
Yeah, I have done all those things.
window, sir, window.
Yeah.
Which one?
We did the same thing.
And next you have to click the presentation which you need to share.
Yeah, that's right. I did the same thing.
Yes.
So somehow I don't know why this is not coming down. Okay, let us try it again and then try the entire screen again. So how
Sir, nothing is visible, sir.
Your window is shared, sir, but not your slides.
No, window is not.
Window is shared. Okay, I shared the PPT
Slides
also.
are not at all shared.
I shared the PPT also.
Sir, one option could be you can save the presentation in PDF format
Okay.
and
Shall I
then
upload
open
to
it
you?
using the browser.
Okay.
You can save the PPT quickly in PDF format and open in the browser and try sharing that.
Okay, do that. So let me just give me just a minute. Just give me 2 minutes. I think it is done now. So is it visible now? Hello.
Sir, now window is visible, sir.
Is the slides visible?
No, sir. No, sir.
No, sir.
Yeah.
Is it in the PDF format?
It is not in the PDF format.
Sir, is the presentation is in PDF format?
Yes. Yes, madam, it is in PDF format. Hello. Hello.
If
So
not,
then,
you can mail to us, sir, so that we
Yeah,
can
madam.
present and you can
Yeah.
share your
Shall I
views on
mail
that.
it to Rashmi ma'am? I'll mail it to Rashmi ma'am. Is that fine?
Okay.
Yeah. I'll do that. Yeah, I'll do that also. Yes,
Then you can open it in the browser, sir.
I'm just okay now sending it
You
to
can
Saul.
open.
Yeah, I send it to Saul NITK.
Hello,
Yes.
hello,
Hello.
am I audible, sir?
You are madam.
Hello, sir, am I audible?
Madam, you are
Yeah, so
audible.
you can open the PDF in. Okay, you can open the PDF in browser
Okay.
and then try
Opened it in
presenting your
browser.
browser window. Now try presenting your browser
Okay.
window.
I'll do that.
Yeah, you can stop your presentation now once and reshare the presentation.
Yeah, let me do that.
But in India, how do we difference?
Otherwise, I think I send it to NITK. Can you just help me to just present it? Madam, is something visible now? No. Hello. Yeah, madam, okay, I have actually sent the mail to Sol. Maybe Sol people can present display there so that I can talk.
ಪೆನ್ನೆಲ್ಲ ಹೆಂಗ್ ಇಟ್ಕೊಂಡು ಏನು ಪೆನ್ನು ಬಂದಿದೆಯಲ್ಲ ಶಕ್ತಿ ಇಲ್ಲ ಹೆಂಗಸಿದ್ರು ಶಕ್ತಿ ಇಲ್ಲ ಅವ್ರು ಬಿಡ್ತಾ ಇಲ್ಲ.
Hello. Hello, sir. You can stop presenting now once. I'll try presenting from my end. Yes, sir. Just a second.